So yes, good morning all. Myself Omkar. I'm here working as an application engineer in electronics technologies. With also with my colleague here, Shrenik Muthan. We are sharing the MBD expertise today. We are just going to have a webinar or training regarding the model-based definition, how where it can be used, what are the implementation method, and how does it actually impacts your overall manufacturing and design methodology, right? So, before we start, we just have a quick briefing regarding MBD, how it was started and why does it, the necessity of it get started, right? As we all know that from the past, we used to, hand drawing the many things. Then we slowly, after the computer age, we slowly move for the 2D drawings, right? The software being developed for the 2D drawings and parametric drawings. Later on, we now currently we are predominant in the 3D modeling and 3D based industries, right? So in World War II, and nearly into 1940s, there is a need of checking standard to checking various parts and surface finishes. For that, GD&T has been developed. GD&T has been invented. But the implementation of GD&T was quite a bit tricky by using the conventional 2D drawings. So for that, there is a need of a 3D model based definition, because of which we can interpret the GD&T methodology and the checking inspection methodology in a better way. So for that, we use SolidWorks MBD. So let me just quickly share. So what is exactly MBD, right? So a complete digital portfolio for a product definition, like all design intent and tolerance in single sources, eliminate 2D drawing dependency, and it follows ASME Y1441 2012 and ISO 16792 standards currently. Okay, so over here, uh, MBD provides a complete digital portfolio within a single file, a single 3D PDF file, where you don't need to, rely on number of manufacturer drawing, let's say from the scrap drawing, from the initial stage drawing to final drawing, checking drawing, and QC, QA drawings. So there is no need of number of drawings, a number of, printing drawings. You can all have in a single package within your command. So for design intent, you can change or alter the drawing that you really want to showcase or you really want to hide or avoid by the time. You can also provide highlights some of the basic feature. If a surface finish feature need to be highlighted for a specific micron or RA value size, so you can provide that also by avoiding the 2D conventional drawing methodology, right? It's how it is the part gonna look in your MBT. It is just an example that I had showcased over here, right? So in the other slide, as we can see, it's a quick debate, a debate between a designer and a debate between actual machinist or shop floor worker, right? There is always a clash between both of them. The design that we make on in the print doesn't actually get implemented into actual product scenario, because there are many number of avoiding features that get interrupted, because of which design get affected. So it's a quick debate between them. So MBD fills that gap between the communication, non-verbal communication between the designer as well as the machinist. So over here, MBD by using the conventional drawing, multiple 2D views drawing had to be interpreted. Manual updates had been to be done. If update has been done in a single manual drawing, there is no traceability for the drawings. Does it really change, and there's the file keeping or the updating drawing, it doesn't has to be shown. So MBD MBD just avoid that. MBD makes itself is a single source of truth, automated update, and reduce error and faster execution. So once the changes has been done by the designer himself, the shop machinist directly get the updated drawing, which he or she can make as per his need, right? So implementing MBD. So here is the quick, a design methodology. Some few bullet point has been mentioned to validate what exactly the design process start and how it executed. So by design mean build a 3D model. As we all know, we initially it's all start with the sketch and the 3D modeling. Then we add the dimension and GD&T nodes as per our requirement and additional full toolbars. And if we require, if there is an assembly, we add the BOM. So validate capturing PMI of completeness, exploit simplicity views, export draft to verify the tolerances. Okay, the publish and create a 3D PDF. So here a 3D PDF plays an important role. It is not like a conventional PDF where you can, just print it and use the drawing. Here you can actually study, or you can actually give the exposure to the 3D drawing or model itself to for your purpose, for where you specifically want to check. Okay, so it's also very user friendly for the camera models, computer-aided machining to interpret that drawing as well as to make the changes or implement the manufacturing machining for that specific drawing without drawing error. Right? Integrate. You can easily integrate the PLM service 3D experience for a digital portfolio. So you can have the cloud-based system to update your drawings wherever there are multiple companies in the different locations, right? So where MBD can be used again, everyone will be wherever you think there is a need of design, there is a we can implement MBD everywhere. There are some few industries which I have mentioned, but the application is endless again. So there is aerospace industries where the optimization and cut prototypes are very important as per the standards. There is industrial, as we know, the manufacturing industry, the 3D data or CNC machining, right from 3D printers to shop floors and furthermore, healthcare industry specifically. There are the material changes and material upgradation in every year for the healthcare industry, and for that, special notes have been added to drawing, which are very mandatory while following or making the healthcare, because again, it's we are dealing with the health kind of thing, and inspection gets a few more what say a few more criticality while checking the healthcare parts. Okay, automotive and defense industry again. If we go to the automotive, trying a body and white or any different industry where the criticality or the security of your drawing is more important, you can use there also with the secure cloud-based system by using the MBD. Okay, so here we have seen the different types, right, regarding how what is MBD and how we can implement it to the implement to the various industries that we serve. So now we are going to see how the actually the MBD is being used, so that you can get an idea of it. Okay, so over here there is my colleague. He will explain regarding MBD to you. Over to you, Shrenik.
Yeah, thank you, Omkar, for taking us through the basics of or introduction of MBD. Good morning, guys. My name is Shrenik, and I'm application engineer here at Addonics. So I'll be sharing my screen with you. Yeah. Is it visible? Yeah. So here you can see the startup page for SolidWorks. For MBD, you just have to go to add-ins and activate the MBD add-in, and that's it. You can use MBD for that. Here is the thing: you can buy MBD differently, or you can use MBD dimensions to generate your drawing. But with MBD add-in as a product, you can not only give dimensions, you can export the 3D PDF as well, or publish it as e-drawing. मला इको येतं. Hello. Yeah. So I'll show you how to use it. We'll go through it. Here you can see the MBD startup. For first of all, to add any dimensions, we need a part model. So we'll start with that. We'll just open a part that we have previously created. So you can add dimensions using two methods. One is auto dimensioning scheme, and second one you can add it manually. So to add this, we just have to go to Dim Expert Manager, and you can see all the annotations or all the tools you need to use over here. So first one is auto dimension scheme. With help of this tool, we can generate all the dimensions automatically. Then insert dimensions, we can insert our dimensions, or you can see over here as well. Then there are some tools just for adding dimensions or tolerances in this location, dimension, size dimensions, and you can add datums, geometric tolerances as well. So not only you can add dimensions to same part, but you can import the dimensions to the other configuration of the same part. So it will help you reduce the time to create dimensions, and it will smoothen your workflow. So with the help of these tools, we're gonna get started with the dimensioning. First of all, we'll navigate to options and go to document properties, and we'll again navigate to units. So here we can set our units, or we can set our units or decimals or and decimal points that we need. So all the settings can be done from over here. Not only that, if you go to detailing properties, you can choose your font as well as text scale for this. Then you can navigate to Dim Expert. You can add your dimensions on your desired standard. For here we are using ASME Y14.0. So you can see all the standards listed over here. You can choose according to you. For this, we are going ahead with ASME Y14.5. So let's start with the dimensioning. Yeah. For this part, we'll start with auto dimension scheme. Now you can see over here, there are multiple settings that you need to define, or you need to give. So for this part is not turned. So we're gonna start with prismatic. And tolerance type we're gonna select as geometric, and pattern and dimensioning we're gonna go with linear. So you have to select your primary and secondary datum here. So we'll start with primary datum. We're going to select the cylindrical surface inside the tube. And for secondary, a secondary datum, we're going to select this surface. Now, so you can select whether you want to dimension, give dimension or generate dimension to all the all the features over here, or you can according to your needs, like the part and this cut part. But for this one, we're gonna select all features over here, and we'll select. So now you can see it will load all the dimensions. So you can simply add, you can simply edit dimensions. So let, let's say you don't want to see all the dimensions. You just need to you want to see dimensions in top view or front view only. So what I'm gonna do is go to top view, right click on it, and click activate and reorient over here. So it will reorient us to the top view, and it will show the dimensions that are generated in top view only. So let's say I don't want this direction, this dimension. So I just need to click on it and delete it. So with the help of that, it will just delete the dimension. Or let's say you want to edit the dimensions. Let's say you want to overwrite the dimension text. You can do it from here as well. Also, you can see all the properties over. You can change tolerance type over here. So for this, we are using symmetric tolerance type, but we can also use bilateral, or we can also define limit tolerance. All you have to do, add the value that you the differences. But for this, we're going up up next. Let's say you have given multiple fillets, and you don't need to see dimensions of for that fillet over and over again. So you can see there are two dimensions for fillet of radius 3 over here and over here. For this, I just want to combine dimensions for these two dimensions. So all I have to do is select control select both of the dimensions, right click on it, and say combine dimensions. What will this will cause it to combine all the directions. Now you can see there are 29 fillets of radius 3 that are applied to this part. So let's say now you have to publish in this part, uh, this MBD dimensioning in 3D template in 3D PDF. So what I'm gonna do is I'll first of all capture view that I want to I want to publish, and with the help of this, I can simply import all the dimensions. So first of all, I'll reorient this in front view. So I'll say capture 3D view. So it will capture 3D view over here. Let's say we're gonna use one more. Let's say top view again. Activate and reorient. Say capture view, and uh, publish it to 3D PDF. So these are all the types of templates that we have. Not only this, we can edit and customize our 3D PDF templates. For this, we're gonna use this template. After this, I'll just say publish to 3D PDF. I'll give to publish it to 3D PDF. It will take some time, but after publishing, you will just go and see over here our document. So you can see all the dimensions over here for top view, or all the other views. You can click and also rotate it as per your needs. Not only that, this is the front view for it, and this is the other view. So in this way, we can publish it to a 3D PDF. Also, we can add add our logo and change the template, or add any general notes over here by just editing the template. So I'll show you how to edit the template afterwards. First, we'll close this, and I'll show you how to generate or give dimensions manually. We just saw how to give dimensions with the help of auto dimension scheme. Let's open. So again, I'll go to Dim Expert Manager. So let's say I want to give the radial give OD to this flange, or so for this I'll just click on size dimensions and click OK. So you can see it's just like using a drawing but in 3D. So you can see all the dimensions. You can see dimension is generated over here along with the tolerance. Up next, let's give some dimensions for this. Yes, and for this. Okay. Now you can see there are some holes drilled over here. So instead of giving dimensions to each and every one of them, we'll use pattern feature. For this, we'll just click a hole and say okay, and then we'll use location. Sorry, we'll just use size dimensions over here, and we'll click OK. Now you can see it will say there are 6 holes of 7 mm patterned across the flange. Up next, let's say we are giving fillet or we are giving dimensions to a fillet part, which is this. So all I'm going to do is select the size dimension and click on one fillet. What will this MBD does? It will collect all the fillet that are of same dimensions and collect it in pattern and give the dimensions accordingly. So you can see the dimension is populated over here. Not only this, we can also let's say I want to give a dimension to the inner cylinder inner inner diameter of the flange. So you can see it automatically generates a countable dimension type from here. Let's say you don't want it to be a countable, you just want to be a two part with two different dimensions, cylindrical dimensions or diameters. So all you have to do is go to the cylinder, click on it, and it will give the desired dimensions. For the same, for the second piece, I'm gonna do the same. I'll just click, I'll click cylindrical cylinder over here, and that's about it. You can easily give dimension to it. Let's say you want to give dimension, or you want to know how long is this part or the cylinder. So I'll select again size dimension. I'll click on post. Sorry, I'll click on location dimensions and click on these two pieces. So it will automatically, this will generate the dimensions. It's of 12 mm. Let's say show you want to show the dimension from middle of the part to this face. So all I have to do is select the first face, go to create width or a wedge feature. Using this feature, I just have to select two faces of the body. So what will it? It will create a face right in the middle of these two faces, and after that, I'll just give dimensions and select one more face to this, and it will give dimensions. It will generate all the dimensions that we need. So this is of 25 mm. Now let's say you want to check the total length of the part. You select this part and this face and this face, and you say okay, 50. It's 50 mm. But you see there is one more face And as you know, you have designed this product, it lies on same plane, but you have to show it to the vendor as well, or the manufacturer. So we'll just delete this, and again we go to location dimensions, select this face and use this command called create compound plane. So we'll select that and select the other face and say okay. So this will create a single plane for both of on these planes. The condition remains same. Both of the planes should be on a single surface. And we will create the other face for the dimension and see it comes around same.